Let's look at the square root method for solving quadratic equations. To use the square root method, you must have the expression of x squared equal to a constant or a number. And then we square root to get the x or expression of x by itself, remembering that we get two solutions by using a plus and minus to represent them. To show this with our first example, I want to show you how you get the same exact answers with factoring. So we have x squared minus 49 equals 0. We want to solve this equation. In the way we've been doing it so far this term, we would have factored the left side. So x squared minus 49 is a difference of squares, where we use x plus 7, x minus 7 as our factorization. That's equal to 0. And because it's equal to 0 and it's a product, we can set each factor equal to 0, creating two simpler equations that are easier to solve. Those two separate equations each give us a solution. X plus 7 equals 0 gives us that x equals negative 7, and then we get another solution of x equals 7 from x minus 7 equals 0. So we get two solutions, but we do have to factor to do that. If we wanted to use the square root method here, x squared equals 49 minus 49 equals 0, we would go ahead and isolate the x squared first. The minus 49 is there, so we'd move it to the other side. So it would become a positive 49 on the right. And then, now that we have the x quantity squared isolated equal to a constant, we undo the square by square rooting the other side. The thing we have to remember, though, is we're getting two answers by putting in a plus or a minus there. So x is equal to plus or minus 7, which are exactly the same thing that I got over here. We had two answers. One was positive and one was negative 7. So I get the same thing, but as you get used to this square root method, it's very quick, and that's why people like to use it when they have this situation in their equation. So let's look at some more examples. 2x squared plus 5 equals 37. First thing to do is to really identify where that x squared is, because we have to get it by itself. So we have 2x squared plus 5 equals 37. To get the x squared by itself, we need to get rid of the 5 and the 2. Let's subtract 5 first, just like if we were isolating x, this time we're isolating the x squared. So subtract 5 from both sides, and we get 32 on the right. Divide out the 2 that is multiplying x squared, and we get 32 divided by 2 is 16. Now that the x squared is by itself, we can use the square root method. Undo the square by square rooting the number. Don't forget your plus and minus. So we get x is equal to plus or minus square root of 16, and the square root of 16, as we know, is 4. So we get two answers. X is equal to plus or minus 4. So we have a solution set that includes two numbers, negative 4 and positive 4. We can go back and check both of those in the equation by putting them in one at a time. I'll leave that for you. We've done lots of checking. Let's look at two more examples. 4x squared equals 81. We first want to isolate the x squared. There's the x squared. It is being multiplied by a 4, so we have to divide out the 4. So x squared equals 81 over 4. Now, 4 doesn't go in evenly to 81, so let's leave it as a fraction. When we then undo the square by square rooting the other side, we get the square root of a fraction. Now, don't forget the plus or minus. There are two solutions here. Now, next I want to remind you of what you do when you're square rooting a fraction. Turns out the square root property with division is that you can divide or look at the square root as applying to both parts of the division problem. So this would be the square root of 81 over the square root of 4. And individually, we can see that the square root of 81 is 9, and the square root of 4 is 2. So we get two answers of plus or minus 9 halves. So negative 9 halves, positive 9 halves would be in our solution set. Once again, very checkable. Putting those back into the original equation, you'll see that you get 81 on both sides. In our next example, to get the x squared by itself, we need to add the 2 to both sides. So x squared minus 2 equals 3 becomes x squared equals 5 by adding the 2 to both sides. Now we undo the square by square rooting. When we square root the 5, don't forget we get a plus or a minus. Now this time, the square root doesn't come out nice. The square root of 5 is an irrational number, and you would at best get decimal values for it. And you could write those decimal values out if you want to approximate with your calculator. For now, I'm just going to go ahead and write those as the exact value with the square root. Negative square root 5 and positive square root 5 would be in my solution set. Again, very checkable by putting those back into the equation. Let's look at a few more examples of solving quadratic equations using the square root method. If we look at these examples, 2x squared plus 4 equals 40, 3x squared minus 5 equals 2, and x squared plus 25 equals 16 on the first line, what we see is that they are going to match up with using the square root method because there are only x squared terms and constant terms in each of the three equations. That's a clue that it's going to work with the square root method. Now, to use the square root method, we need to get the x squared by itself. So we need to isolate the x squared in each of these situations. So let's do that. In our first equation, 2x squared plus 4 equals 40, we're going to first subtract the 4 from both sides to get 2x squared equals 36. We're going to divide out the 2 so that we now have x squared equals 18. So x squared is by itself. Now we can use the square root property. So we can get x by itself by square rooting the number on the other side. We get two answers, one positive, one negative. Now, the square root of 18 doesn't come out as a whole number, but it will simplify. So I want to remind you of how to simplify square roots. How you simplify a square root is you take out a perfect square factor. So for instance, perfect squares are things like 4, which comes from 2 squared, 9, 3 squared, 16, 25, 36, etc. So numbers that come from squaring a number. If we have a factor that involves one of those inside the square root, we can actually rewrite this as a product involving that perfect square. So 18 would be rewritten as 9 times 2. And there's a rule with square roots that we can go ahead and break that into the product of the individual square roots. So the square root of 9 times the square root of 2. And the square root of 9 is a perfect square, so it simplifies. So I get x is equal to plus or minus 3 times the square root of 2. So that would be the simplified result. So we have two solutions. We have a solution set that has negative 3 times the square root of 2 and positive 3 times the square root of 2. Let's look at the next two examples. 3x squared minus 5 equals 2. To isolate the 3x squared, we're going to first add the 5 to both sides. So we get 3x squared equals 7, and then divide by 3. X squared equals 7/3. Again, that fraction doesn't simplify, but we're going to leave it as a fraction. Undo the square by square rooting, so x is equal to plus or minus the square root of 7/3. Remember, we can square root the top and bottom of that fraction. So we get plus or minus the square root of 7 over the square root of 3. And then in mathematics, we typically do not like to have a square root in the denominator. So we do what's called rationalizing the denominator, which means that we're going to adjust this fraction, build it so that we have a non-square root in the denominator. To do that, we're going to multiply by a factor of 1. The one we choose is going to be whatever the square root is in the denominator over itself. So we're going to multiply both top and bottom by that square root. In this case, the square root of 3. So when we do that, we get x is equal to plus or minus the square root of 7 times 3 is 21 over the square root of 3 times the square root of 3 is the square root of 9, which simplifies to 3, and the root in our denominator is gone. So our answers to this equation would be negative square root 21 over 3. Again, there is no root in the denominator anymore, and positive square root 21 over 3. So again, we would want to simplify our square roots when we can. Sometimes that involves removing a perfect square. Sometimes that involves rationalizing. In our last example, we have x squared plus 25 equals 16. We would want to subtract the 25 from both sides. 16 minus 25 gives us a negative result, negative 9. When we go to square root here, x is equal to plus or minus the square root of negative 9. And a reminder that this is not a real number. The square root of negative 9 is not real. We can express it as an imaginary number, though. Anytime we have a square root of a negative, we can take that negative and think about pulling it out as what's an I factor. we define I as the square root of -1. So I'm basically pulling out the square root of -1 separately and calling it I for imaginary number. What would be left is the square root of 9, which simplifies to 3. So I'd have x is equal to plus or minus I times 3. And generally, even though I is not a variable, it's a representation of an imaginary number, we would typically, if we were writing x times 3, we'd write 3x. We do the same thing with I. So we have two solutions, positive and negative 3i. These are imaginary solutions in the imaginary plane, negative 3i and positive 3i. So we haven't really dealt with imaginary solutions up until now, but you probably have had them discussed in a previous math class. And here's a reminder of how they come up with a quadratic equation. I have two more examples I want to look at. 5x squared minus 4x equals 2 times 10 minus 2x. Now when you first look at this example, you might think, well, there's b terms there, bx terms, I should say. Take a pause and think about how we would normally work with equations, which is to simplify each side. And then if we think we're going to need to use factoring of the quadratic formula, get things on one side. So let's do that. Let's simplify this. 5x squared minus 4x, those are not like, so it doesn't simplify. But I can distribute the 2. 2 times 10 is 20. 2 times negative 2x is negative 4x. Now when I go to move things to one side, so I get 0 on one side, I'm going to move that negative 4x over. And when I do that, those 4x's are going to add up to 0. Negative 4x plus 4x is 0. So I do get a situation where the bx term goes away. Now if it hadn't, I would have continued moving things to one side to get 0 on the other, and then factor or use the quadratic formula. Since the bx term went away, I can continue with the square root method. So divide out the 5, x squared equals 4. And here, when I square root, I get some nice numbers. I get plus or minus the square root of 4, which is plus or minus 2. So I have two solutions, negative 2 and 2. Again, all of these solutions I've been going through, you can plug them back into the original equation and check. So don't forget to do that. In my last example, I wanted to show something that's a little different that will come up just occasionally where you can still use the square root method. What we have here is an expression in terms of x that's squared equal to a number. Now, I mentioned earlier when I defined the square root method that you have a capital X. I used capital X for a reason, squared, because this can be x or it can be an expression of x or any variable. So as long as we have something involving x squared by itself equal to a number, we can proceed with the square root method. But this time, instead of getting out just x here, I'm going to have x minus 5 equals plus or minus still with the square root method of the square root of that number 16. Simplify that stuff. X minus 5 equals plus or minus 4. And then to get x by itself, we need to add 5 to both sides. Now I want you to be really careful. I'm going to write this out longhand. X is equal to, negative 5 becomes positive 5. I'm going to write it first. And then we're going to add and subtract 4 because this is really positive and negative 4. When I do that, I'm going to get two different answers. Sometimes people just want to add the 5 to the 4 and get plus or minus 9. But that won't work because adding 5 to a positive 4, and I'll write it out, is not the same as adding 5 to a negative 4. And when we look at them written out as calculations, we can see that 5 plus 4 is 9, which is what we suspected, but we don't get a negative 9 when we have a 5 minus 4, we get positive 1. So it's really important that you think about this as two separate calculations when you use this, this kind of a technique with a problem involving an expression squared equal to a number. Two separate calculations. So make sure you do that so that you can get correct results. And the solution set here would be 1 and 9. Again, very easy to check. If you put the 1 in, you get 1 minus 5 is negative 4. Quantity squared is 16. And 9 minus 5 is 4. 4 squared is 16. Both of them check. So that's a real quick reminder of how we work with square roots and use the square root method.